Okay, here's our last problem. So we got 2 times log base 5 of x plus log base 5 of 2 equals log base 5 of 4x plus 6. So again, I try and think of different properties of logs that I can use to rewrite this. The power rule is 1, so I could write this as log base 5 of x squared. Okay, and I'm adding to that log base 5 of 2. And that is going to equal log base 5 of 4x plus 6. Okay, I had printed around here so we keep track of everything. So I can now use my product rule. I'm adding two things together here, so that means I can multiply the stuff on the inside and write it as a single log. So log base 5 of 2 times x squared. Now I switched their order because I don't like writing x squared times 2 because it looks weird. For whatever reason, we usually put the numbers in front. So don't let that confuse you. I just switched the order of the multiplication. Doesn't matter. Still the same thing. So we got 2 times x squared. And on this side, we got log base 5 of 4x plus 6. So we have, again, one log on each side. So in spite of everything else that we've been doing, our goal is to basically take stuff that looks kind of complicated. We got lots of parts here, and reduce it down to one single log on both sides that we're then able to use the equality principle. Okay, so that's the general idea of what we're trying to do here. And now because of that, I can use my equality property and say 2 times x squared is equal to 4x plus 6. Okay, so now to solve this, now notice you have an x squared and there's nothing, no x's to divide it by. Sometimes kids will try and divide both sides by x, but that turns out to be pretty ugly because you can't divide just this by x. You got to divide the whole thing by x. That doesn't really help us. So how do you solve something that has an x squared in it? Well, that should be a sign that this is quadratic because we have the x squared. So what that means is we're going to have to do something like the quadratic formula, or we're going to have to factor it, or complete the square. Some of those things you learned in math too. But the first thing I got to do is get this equal to 0. So I'm going to subtract 4x and 6 from both sides and get them over here. So subtract 4x, subtract 6. Now there's no x's to subtract from and there's no numbers to subtract from. So these will cancel over here, but over here you're going to have 2x squared minus 4x minus 6. And then it's going to equal 0 because everything else canceled. Okay, so how do we want to deal with this? We could factor it. If we use the quadratic formula, so a is 2, b is negative 4, c is negative 6. Okay, now I can do my formula, which is negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. Okay, and you can look that up. We don't expect you to memorize it. Just Google quadratic formula. It'll be all over the place. So I'm just going to plug in my a, b, and c into this equation. That's going to give me negative 4, which we can later turn to a positive 4, but for now I'm just going to leave everything as is, plus or minus the square root of b squared, so that's negative 4 squared, which again will be 16, but we'll deal with that later, minus 4 times a, 2, times c, negative 6. Can put in parentheses so I don't forget that I'm timesing it. Don't want to come back to that later and think I'm subtracting it because I'm not. And divide all that by 2 times a, which is 2. Okay, now to clean this up a little bit, negative 4. I'm going to change that to a positive 4 now. Still have my plus or minus sign. We'll figure out what's in the square root in a second. Down here, 2 times 2 is 4. Okay, so negative 4 squared is 16. So over here, this stuff, 4 times 2 is 8, and 8 times 6, let's see, 6 times 8, 48. Okay, but it's a negative, a positive, and a negative. So multiplying those together will make a positive number. So positive 48 plus 16, that comes out to be 64. Okay, and that's nice because I know the square root of 64 is 8. So this is 4 plus or minus 8 over 4. So we're going to have two things here. 4 plus 8 is 12, divided by 4 is 3. Okay, and then we're going to do 4 minus 8. So 4 minus 8 is negative 4. Divide that by 4, and we get negative 1. Okay, so I have two solutions, apparently. X equals negative 1 or 3. Okay, so that's kind of weird. Let's double check those both. So let's first start with 3. So we got 2 times log base 5 of 3 plus log base 5 of 2 should equal log base 5 of 4 times 3 plus 6. Okay, so 4 times 3 is 12. 12 plus 6 is 18. So this is log base 5 of 18. Okay, so I could type in log base 5 of 18, and I could type in 2 times log base 5 of 3 plus log base 5 of 2 and see if those equal the same thing. Okay, but I would like to practice my log properties, so I'm going to use my power rule here and say this is log base 5 of 3 squared. Okay, which is just going to be 9. So I'm just going to change that now to a 9. Okay, plus log base 5 of 2. And that needs to equal log base 5 of 18. Okay, so the next thing I can do is I can use my product rule. So it's going to be log base 5 of 9 times 2, which is log base 5 of 18, because 9 times 2 is 18. So this does come out to be log base 5 of 18 is equal to log base 5 of 18. So that means that 3 worked. So 3 is good. Let's try it with negative 1, see what happens. Okay, so 2 times log base 5 of negative 1. Okay, so here's something interesting. Log base 5 of negative 1. How many times would you multiply by 5 to get negative 1? Well, 5 is positive, so no matter how many times you multiply by 5, even if it's a fraction of a time, it's never going to equal a negative number, at least not with real numbers, right? So this is actually undefined in the real numbers, which means that this isn't going to work. And you could carry this out and see that it actually does lead you to gibberish. Let's look at the graph of these so we can show you what's going on. Okay, so here I got my graph of log base 5 of 4x plus 6 in blue, and I got my graph of 2 times log base 5 of x plus log base 5 of 2 in black. Okay, so you can see when x equals 3, they're going to equal the same thing. They both equal 1.796. In fact, you can come over here, type in log base 5 of 4 times 3 plus 6, and I get 1.7958, yada, yada, yada. And, okay, and if I do 2 times log base 5 of 3 plus log base 5 of 2, I also get 1.795. So that is showing that 3 is a solution. Okay, so x equals 3 was a good answer. Now, what about x equals negative 1? Well, if you look at our graph, so here's x equals negative 1. We're counting by halves here. So this is negative 2, negative 1 would be here. The answer exists for the blue graph, log base 5 of 4x plus 6, it's going to come out to be 0.431. But if you look at the black graph, it doesn't go over that far. That's because any x values less than 0 aren't going to make sense, because you're going to be asking how many times you multiply by 5 to get a negative number. And so because of that, x equals -1 is what we call an extraneous solution. It's a solution that we get when we solve it formally using our equations like we did, but it doesn't lead to an answer that makes any sense with the original problem. Okay, so out of these two solutions, only 3 really works. Okay, so x equals 3, not -1. Even though we got that as an answer, when we check it, it doesn't make sense. So that brings up a point: when you're solving log equations, you should always check your work, because sometimes you'll get answers that don't make any sense. And it is possible to have two logs that, going back to our picture idea here, it is possible to have two logs that don't ever cross each other. Okay. For example, if I maybe adjust this to be a -6. Okay, so these logs will never cross. There will never be a solution. And if I tried to solve these, it's not going to be an answer that is meaningful. So you should always check your work to see if you have extraneous solutions. Okay, if you have any more questions, let me know, and good luck.